Back to Device Talks Tuesdays. We've got a excellent episode today. I always enjoy talking about surgical robotics, and we've got a great panel from which we can learn. We'll talk about the various some larger issues surrounding surgical robotics, but we'll also delve into some very cool new surgical robotic technologies that you'll have a little bit of a demonstration of today. So the title is The Future of Robotic Assisted Surgery in Orthopedics. We've done a lot of talk about surgical robotics. A lot of it, the innovation, or at least the news, has sort of been centered around soft tissue. Today we're going to be talking about orthopedics and hard tissue, so lots to talk about. Before we get into that topic, though, I want to remind you that this event is available live to you right now, but it's also available on demand to anyone who's foolish enough not to come on live. If you know someone who should be listening to this information, who would benefit from these insights, and I'm sure there are many, let them know it's not too late. They can register at devicetalks.com. They can watch on demand. They'll be able to ask questions. They'll have access to the PowerPoints, which are very few, but they'll be able to listen to the conversation and, again, ask questions, and we'll make sure those get to the appropriate folks. So it's not too late for folks who have not registered for this event. And folks can also download on the resource widget. There's a white paper that folks can download that will provide even more information. So it's all available if you're watching now or if you're watching on demand. So make sure, if you know of someone who would, again, benefit from this conversation, let them know it's not too late. Speaking of questions, I'm going to be leading a conversation with our panelists, who I'll introduce in just a moment, about various elements of surgery, various aspects of surgical robotics. Your questions are welcome as well. Ask them as they come to mind. If we can take them on at that time, we will. If we need to, we'll save probably the bulk of them for the end. But don't wait until the end to ask your questions. Keep them coming, and we'll make sure we have an engaging conversation of which you can be part of. Finally, if you're mentioning this on social media, please use hashtag DeviceTalksTuesdays on Twitter or LinkedIn. That way we can be part of that conversation. We can know what's going on and be part of your social media experience. So please make sure you use hashtag DeviceTalksTuesdays. Before we begin, just want to let you know Device Talks West is happening. That's our in-person meeting at SAC beginning October 18th and 19th. Sagentia is also a great sponsor of our in-person events. Very happy to have them here on our digital events as well. So make sure you check out the agenda. We just posted it. It'll be at devicetalks.com. Finally, while you're at devicetalks.com, make sure you check out our many podcasts on our Device Talks podcast network. You can see them all up there, I think. They keep coming. So go to devicetalks.com to check out future events and future podcasts, and you can also subscribe to those on any podcast player. All right, but now let's get into our conversation. Thank you again to our friends at Sagentia Innovation for putting together this excellent panel. We're going to start off with some questions, but I'm very happy to have today Rob Morgan. He's Vice President of Medical at Sagentia. We've got Stuart Simpson. He is President and Chief Executive Officer at Think Surgical. And finally, we have Tim Fearson. He is of Sagentia Innovation. He's the Timini Program Manager. I realized I asked him how to say his name. Am I saying Timini right? Is it Timini? Should I say that, Tim? Oh, I think everyone's muted. You can all bring up your microphones and join the party.
Timini is the right way.
Timini. All right, Timini. I didn't look down at the product. That hasn't tripped me up before. But thank you, gentlemen, for joining us. So let's just talk about how we all got here today, but more precisely, how Think Surgical and Sagentia Innovation came to be working together. Stuart, maybe you can kind of lead us off, and then we'll bring Tim and Rob into the conversation.
Okay, perfect. Thank you for the invitation to be part of today's event. I wasn't here at the time. I think it was around about 7 years ago, but the leadership at the time and the investors behind that management team were at Think Surgical working on bringing their own robot to market. And they were deep in the development cycle. But they had this really cool concept from an innovator and an inventor called Joel Zuhars. And this concept for the wireless miniature handheld robot was kind of a dream of his. And as a company, they didn't have the bandwidth to be able to continue to develop their existing product and work on this concept. So after an extensive search, they decided that the innovation partner that could best help bring that concept to life was Sagentia. And we've been working with them ever since. And it has been a remarkable story in innovation and concept development and technological advancement that has actually ended up delivering the product. So we've known each other for a long time. We've worked well together, and we've enjoyed the relationship with our partners at Sagentia.
Fantastic. And let's bring in Tim and Rob. You guys can decide who goes first. I know, talk a bit about what Sagentia does in this space. I know you've written a great deal about it. We talked about the white paper. Rob, I remember reading an article that you had in the MedTech Strategist a couple of years ago. So you folks have been at this for a while, but one of you kick it off. Tell us what Sagentia is doing in this space.
Well, I'll lead off here. Thank you, Tom. And great to be joining you all today. We do loads of work in this space. We're a technology and product development partner for our clients. We provide R&D services to our clients across medtech and other industries. And within that, we do a lot of work in surgical robotics. And we've been involved with Think Surgical in the development of T-Mini from the very start, as Stuart was describing. So we've worked on that since the initial concept was developed, all the way through product development, transfer to manufacture.
Tim, you want to amplify that at all, or is it well stated?
Absolutely. So, I mean, thank you, Stuart, for the introduction. So I've been working with the Think team over that period of time, from when this started as a product development, and it has been a thoroughly enjoyable experience. Lots of technical challenges that we've overcome collaboratively as a team, and also to see it get to where we are today with 510K submission, having been involved from the very initial concept all the way through to where we are now, and this product, this system going onto the market it's been an awesome experience.
That's great. And Stuart, just to make sure I'm certain, what's the status of the T-Mini system? We talked about FDA. So where are you with FDA approval and commercialization?
Yeah, we as a team managed to file with the FDA in early January this year, and by the end of April we had clearance from the FDA. So currently FDA cleared. We're completing the documentation, design transfer, and all of the quality documents that we need to complete. And we are gearing up to start shipping the product in the next few weeks. So it's an exciting time for us after all these years to see the concept become a reality and a product come to life.
I bet. Well, I'm even more grateful you took some time to talk with us today. I'm sure you've got a lot going on. So let's talk about the clinical needs in joint replacement surgery. I mean, there's been a system out for over a decade now. It was an area initially where there didn't seem to be. Surgeons would have told you that knee replacement in particular was had such a high success rate. There wasn't even a need for this sort of technology, but there clearly was. It's a growing market. So talk a bit about what were the patient shortfalls and what were some of the challenges facing surgeons at the time. And once again, Stuart, we'll let you kick it off, and then we'll bring the rest of the panelists into it. And before we begin, I'm already seeing some questions from the audience. So thank you for submitting those. Keep them coming. We'll make sure we get to everybody.
Okay, perfect. So when you go back to the 80s, 90s, and early 2000s, there was a lot of significant progress in product development and design, in materials, in manufacturing processes, and well, not all of them, most of them were very positive innovations that improved the quality and performance of the devices for knee surgery and improved the outcomes for patients. But by the sort of 2010 timeframe, it became clear to some of us in the industry that incremental design changes on an implant weren't going to meaningfully improve the outcome of surgery for the patient. And that's what led to the interest in robotics. And as you know, Stryker at the time, 2013, made a bold move in acquiring Mako Surgical. And that really kicked this whole thing off. And the clinical hypothesis was that if you can do the surgery more accurately, more reproducibly, and personalize the surgery to the patient rather than using a standardized surgical plan, you could improve the outcome of the surgery for the patient. The clinical outcomes would be better, and the satisfaction levels would therefore be improved with the current implants that were available at the time. So that's what the premise was for Stryker acquiring Mako. That's what kicked this whole thing off. And I think that there's increasing evidence that that is actually the case. And we're seeing some of that come through in the clinical data that is being collected in joint registries and in other areas. And, you say that joint replacement surgery had very high success rates. I would say that was true of hip replacement, but there was still this big group of patients who had a knee replacement surgery that were dissatisfied a year or two after the procedure. Maybe 2 in 10 would say, I don't know that I'm happy with the outcome. So there was definitely an opportunity to improve, and we believe that technology and more precise surgery is delivering some of that improvement. So that's why we're here.
That's a great point. I remember the rates being reported, high success rates, but then as you sort of dug it into it a bit more, and as you said, check up, follow up 1 or 2 years. It wasn't quite what at least I was told it was. Rob, I mean, can you sort of add to that about the clinical needs in joint replacement? What was needed, and how are we doing? How is the new technology working to address some of that?
So adoption of robotics is certainly increasing in orthopedics. I would say most strongly in the US hospitals, and most strongly with cementless knees. And beyond market adoption, you have to look at the data to really answer how well it's doing and what impact it's having. And I guess I'm most interested in the data that's directly relevant to patients in terms of their long-term outcome. And so there you have to look at survivorship, the length of time that the primary implant lasts in the patient before they have to have revision surgery. And you also have to look at patient satisfaction, like Stuart was talking about, and how that's quantified in clinical studies with so-called patient-reported outcome measures. So if you look at survivorship, I mean, it's become pretty good in these. Certainly, it's improved in the 25 years I've been around the industry. You'll see some implants now showing survivorships of 90% at 20 years. So that's, in some ways, knees is catching up with hips. And there is early data showing that robotics improves that further still. I say early data because it's kind of 5 years out, and you have to then extrapolate those survivorship curves out to 10 years and out to 20 years. So for survivorship in total knee replacement, I think time will tell how big an impact robotics is having, but the early signs are good. And then in terms of patient reported outcomes, and typically that's quantified with scoring systems that look at pain, they look at stiffness, they look at functional outcome in order to quantify that dissatisfaction level, which, again, as Stuart was saying, 20% is quite significant dissatisfaction. And the hope is that the more accurate alignment you get of the implant with use of robotics and the better soft tissue balancing you can achieve with robotics will improve those scores. And again, early clinical data suggests that that's what's happening. Hip replacements is the other place to look. Robotics is less strongly adopted in hips and knees, but it's increasing. Survivorship's already pretty good in hips. I think it's more important to look at complication rates in hips. So the number of patients suffering from dislocation, the number of patients who get limb length discrepancy after their surgery, and the data suggests that robotics improves that. But the interesting thing is despite that encouraging data on robotics and the improvements that you see in the clinical data, it's still not that strongly adopted. It is in certain segments, but there must be a barrier to more widespread adoption of the current robotic systems that you see in orthopedics.
Interesting. Great. So again, we've got good questions coming in from folks. Please keep them coming. Tim, let's kind of follow that a little farther. To what extent have the needs been addressed by surgical robotic technologies out there?
Sorry, so to what extent have needs been addressed, did you say?
Yeah, let's just continue the needs. Yeah, not the knees. I'm sorry, the needs. How is surgical robotics doing in addressing the needs that Rob and Stuart have laid out?
I think they've certainly made a good start. I think there's still plenty of work still to do in this area, and I think there's obviously more. There's a need for more the technology to come through. I think there's certainly in the product that we've developed with Think Surgical. I think there's certainly improvements to how the technology, how the robotic system integrates into the surgical workflow. I think obviously there's, and that's a key piece, acceptance from the surgeons of the system. Certainly if they're more focused on manual procedures currently, so opens up the a vast opportunity, I think there for a lot of sort of surgeons who are focused more on the manual procedures and introduce them into surgical robotics. I think once the door is open, I think more will come. And obviously there are key potential key benefits to in terms of patient outcomes through better accuracy of implant placement.
Tom, I would add that just like in soft tissue, orthopedic robotics really is in its infancy, and yes, it was 10 years ago that acquisition occurred. Yes, it was 15 years ago that the industry or surgeons started using robots for joint replacement surgery, but it's still in its infancy. There is increasingly some clinical data to support the use, as I said earlier. There's increasingly trained physicians coming out of fellowship programs that are trained in this technology and want to use it. And increasingly, those patients are actually asking for it. So there's a lot of tailwinds, but there's a couple of big headwinds. And one of them, which is addressed by the product that Surgentia have helped us bring to life, is the form factor. The current robots are mostly very large, 700, 800, 900 pound pieces of equipment that are wheeled into the operating room, whereas this device, T-Mini, is a miniature wireless handheld device, which is about 7 pounds. And it integrates, as Tim said, seamlessly into the current operating room workflow for the surgeon and operating staff. So we believe that this is the opportunity for the majority of the market to start to embrace robotic joint replacement, instead of it just being the innovators and early adopters who would put up with those large, complex, heavy pieces of equipment. We believe that this is much more simple and elegant and easy to introduce for the majority of the market. So I really have to take my hat off to the folks at Surgentia for the innovation that is inside this device. Its simplicity understates how much innovation is built into it.
Rob, you want to speak to that a bit more as to the barriers that have existed that kind of has held back the deep penetration?
Well, I think another barrier that we've yet to talk about is the way in which the majority of the systems out there are closed systems. So they're systems which can only be used with the implants provided by the same manufacturer that provides that robot. Now, that's a certain model for providing the equipment to the market, but it is limiting. It's limiting in the choice of the surgeon. So if the surgeon wants to use robot system X and they want to use the implant from manufacturer Y, they're limited in that choice. Now, the T-Mini system, the approach that Think Surgical taking is actually quite different. So that's an open platform and provides a lot more choice. And I hope that will overcome one of the barriers that you see in the market.
Terrific. Tim, I feel like we've set up the conversation for an opportunity to introduce folks to T-Mini. So why don't we show them the system a bit, and then we get back to our conversation.
Sure. So
we have a video. We're gonna play it once quickly, and then we'll go over it again more slowly so we can break it down.
That's right. Thank you, Tom. So the T-Mini robotic system is comprised of a wireless robotic handpiece to help surgeons perform total knee replacements. So this is sort of from what Stuart was mentioning. So it uses CT-based three-dimensional surgical plan to automatically compensate for surgeon hand movement and locates bone pins precisely along defined target planes on the operative bones. So universal cut guides can then be placed on those pins for accurate bone resection. So let's go back to the video. If I advance it on again, play the video, I'll talk it through each step by step. So here's the T-Mini, the T-Mini handpiece. It's placing pins on that pre-planned target plane. And here we have a universal cut block placed on those pins for the initial resection on the femur. And again, in this image, this video here, the T-Mini's second plane is being selected to again place pins on a pre-defined target plane. And in this case, a drill block has been placed. And then we're drilling effectively pilot holes to then place an implant, specific implant manufacturer's 4-in-1 cut guide. And then the final resections are carried out. Okay. All right. So let's just move on to the next. Go ahead.
Tim. So what's not shown in that short video is that T-Mini is a camera-based system, and just like the larger robots, the patient or the surgeon can put the patient's leg through a range of motion and assess the soft tissue envelope for the patient's knee. And that's very important information in robotic surgery, because one of the big steps forward with the introduction of this technology has been the ability for a surgeon to adjust on the operating room table the plan according to the actual soft tissues, actual ligament tensions, and actual range of motion of the individual patient. So T-Mini, despite being this miniaturized robot, 7 pounds versus 700 plus pounds, still has all of that personalization capability that the large robots have. And I think it's an important point to call out, because I personally believe that that is one of the main reasons that the patient-reported outcomes and some of the clinically observed outcomes have improved with the introduction of robotic surgery. So, sorry to jump in, Tim.
No, that's That's fine. That's absolutely fine. I think if we move on to the next slide, so we can see here is, you can actually see on the left-hand side is the T-Mini handpiece, and on the right-hand side, we have the navigation cart with the graphical user interface. And on the end of the navigation, on the boom arm there, you can see the 6-camera tracker. And then you can see it in relative size to the T-Mini handheld below. So if we just advance onto the next slide.
Should be up. Do you have it?
So I think I'm got delay on the side.
I'm seeing the slide with the circles.
That's right. Yep, I'm not seeing it just yet.
It's up.
I'm actually my screen is locked up. Bear with me.
Okay. Okay,
so it's up. Great.
Yeah, you can always hit refresh if you're having a problem. It'll come right back on. But go ahead.
Okay, I will. I'll keep going. You saw the video. You've heard about the concept. It sounds really simple, and the concept is very straightforward. But the engineering behind the system is pretty complex. So the T-Mini system is really a collection of technologies. Each technology has been developed, then integrated, then optimized within this single system. And it consists of each of these core technologies. And we'll go through each of these in just a little bit of detail. So we'll start at the top. So we have CT-based preoperative planning software to create the surgical plan. We have the navigation cart with the graphical user interface to help guide the surgeon and technicians through the various workflows. Attached to the navigation cart is the 6-camera tracker, and that has integrated two-way communications with all of the actively tracked devices. It also has an integrated visible light camera, and that helps to position the tracker within the tracker's field of view relative to the patient. Moving around, we have the actively tracked autoclavable digitizer, which is used to register each of the operative bones relative to the bone markers. We also have the bone markers themselves, which again are used by the system to track each of the operative bones post-registration. And then we have the T-Mini, which we saw the video. So effectively, it has the capability to track to those pre-planned target planes to accurately place bone pins to then place the cut blocks to make the necessary resections. And last but by no means least, we have the universal cutting blocks as well. So they're placed on those inserted pins to allow the initial tibia and femur bone resections to take place. So once those navigated pins have been placed and those resections made, so the surgical workflow is then completed using standard surgical power tools and a specific implant manufacturer's 4-in-1 cut block, as we saw in the video. And that's what's indicated on the left-hand side there.
All right, great.
So this is as I was mentioning, it on the surface, it looks
Oops.
I think we've lost him.
I think so, yeah. I think Tim may need to refresh. I don't know if he's having some internet problem. He was voted off the island. Oh, Tim.
but behind complex engineering.
Hey, Tim, are you able to hear us?
I can hear you, yeah.
Okay. Would you mind just hitting refresh? You were kind of cutting in and out a bit. I think we just need to
okay.
start from zero. Oh, not the whole presentation, but just the last few seconds.
Okay,
so,
I'm trying the refresh.
Okay. I'll just jump in here for a minute.
Yeah, please. I was going to say, yeah. How does this change things, Stuart?
I mean, there's a lot of really advanced technology in here, and I would call it even cool technology. And I have to say that this device is the main reason that I decided to join Think Surgical as a CEO. I do think that this changes the landscape, and But before we get into talking about that, I want to emphasize a couple of points. First of all, the camera system that we're working with here, there have been huge step forward achieved in this project in terms of not just camera technology, but the software and the overall system latency that it delivers. Because for a handheld robot, you need a much more responsive communication between the camera and the device than you do for example, for a large robotic arm. So there's a lot of real secret sauce in there. And part of the reason we went with Surgentia Innovation is not just their own internal expertise, their incredible breadth of talented R&D engineers in Cambridge, but because of the network of contract development and manufacturing partners that they had around the world. And the partnership between Surgentia, the Think engineers, and these third parties has led to some significant technological breakthroughs in this particular area. I'd say a lot of the software expertise for that is with our Canadian team, the Think surgical team up in Montreal. But in and of themselves, they wouldn't have been able to achieve this. It really was a partnership between Surgentia, Think, and external partners. And then the handpiece itself, I think of this like, you know, when you see a movie being shot and you see the cameraman that's got the balancing or vibration adjustment device, that means that there's a perfect shot every time, even when they're running across a scene or they're moving quickly with the actors. That's exactly the type of experience you get with this device and camera combination. There's a three-dimensional model created from the CT scan. The patient is then registered to that model. The device then knows exactly the plane for the bone resections that have to be identified. And as long as the surgeon's hand is close to the correct area, the device operates and then adjusts real time to any small or larger hand movements that the surgeon makes. And if it goes outside of the active plane, it just shuts off. So it delivers exactly what it's supposed to deliver every time and adjusts for any surgeon, small or larger hand movements that might lead to some inaccuracies. And it really is quite a cool experience when you first put your hands on it. And like I said, it's the main reason I decided that there was a huge opportunity to come to Think and take this technology and bring it to market, because I do think that it does change the landscape significantly.
And that's great. We've got a bunch of questions from folks. We'll get to them very shortly. But Stuart, just wrapping up on this part, how does it change the business model? It's a smaller robot, lower price point, I'm guessing. how is it?
Yeah, we'll go back. There's probably three things. Two that we've already talked about. There's only about, nobody likes to put out a number on what the total market is here. I actually believe that I have a number of what the total market opportunity is for joint replacement robots. And I believe that market's about 15% penetrated by the end of 2022, which means that 85% of the market opportunity is still out there. And because of the tailwinds that I described earlier, I believe that the adoption is going to accelerate, particularly if we can overcome three things. One is form factor. We've talked about how the miniaturized handheld device is much easier to use in the operating room than the large complex robot. So that's point one. Point two, as Rob mentioned, is the commercial one. Most of these devices are supplied with only one company's implants. So the company that makes the robot will only let you use their implants. Think Surgical doesn't have any implants. We are a robot and digital surgery company. We believe in customer choice. We want to create a robotics platform where the surgeon decides which implant is best for each and every patient and supports the preferences of multiple different surgeons. So we'll put any implant on our platform if the company wants to add. And we currently have 4 partners, and we're going to be adding a lot more partners over time. And the third thing is obviously the economics. These are expensive devices, and there are consumable costs associated with them. The miniaturization of the technology brings it in at a completely different price point. So we're excited that we're overcoming 3 major barriers to adoption. I think it changes the landscape because it makes the technology accessible economically, workflow-wise, and business model-wise to the majority of the market.
And we had a question from Allison, and it's a good one. I mean, the rise of ambulatory surgery centers, is this going to be more palatable for smaller businesses like that?
Yes. This is a simple answer.
Next question. Okay. Serves me right for asking a yes or no question.
Absolutely, but not just that. You know, our segmentation is more about consumer attitude and customer behaviors, and those innovators and early adopters that have pioneered the way with the larger, more complex systems. We owe them a lot, but we're appealing to the majority of the market who, for one reason or another, haven't adopted the technology yet, despite some of the tailwinds we mentioned earlier. And they are likely to operate in hospitals as well as surgery centers. But yes, the surgery center model fits what we're doing particularly well.
All right, and I'm going to just run through a few of these questions. We'll get back to the conversation as well. And if you covered this, I apologize. I was managing something. Is T-Mini compatible with cemented and cementless implants? Both?
Yes.
Yeah. All right. And again, these questions came on earlier. Is it available to products outside? Do you use your own implants, or are you compatible with other implants?
We do not have any implants. We support other companies' implants on our platform, and we hope to attract all companies' implants to our platform eventually.
Rob, how unusual is that universal quality? I mean, I think most people see surgical robotic systems as basically ways of selling your own particular implant if you want to compete in surgery, particularly on the soft tissue side. Are we seeing things from soft tissue that are moving into hard tissue? And again, how unique is that universality, that open platform for surgical robotics?
Yeah, I think there are a lot of parallels between soft tissue robotics and orthopedic robotics, but there are real differences. But maybe looking first at the parallels, because the first soft tissue robot that was adopted in the mainstream was the Da Vinci system, and at the time, you know, that kind of followed a different path than we're seeing in orthopedics. Intuitive Surgical wasn't one of the major providers of instruments or implants into general surgery. So that's a bit more like the open platform system that we're thinking about with Think Surgical. But the point I was going to make in terms of the parallel there is the way applications have increased in number on each of the soft tissue systems. So, I mean, Da Vinci was originally adopted in gynecology and urology for hysterectomy and prostatectomy, and then expanded into general surgery, into hernia repair, into gallbladder removal. And I think we'll see exactly the same thing happen in orthopedics. Currently, it's most strongly, robotics is most strongly adopted for cementless knees. The systems are getting extended for usage in unicompartmental knees and to total hip replacement. And I think you'll see more more types of surgery, more types of implant become used in the orthopedic system. So I think that's a parallel. One of the main trends that I see in soft tissue robotics is the way that it enables more minimally invasive surgery. And of course, that was one of the premises for those robots, that it would switch users from open surgery, open abdominal surgery, to robotic lap surgery. And it's extended even more now with the proliferation of endoluminal robots, which are in development and are reaching market and allow scarless, incision-free, natural orifice surgery. And I don't really see that happening in orthopedics yet. So incision sizes, I think, are largely the same, whether you go with the robot or manual. But the same drivers are there. The same drivers are there in terms of wanting to decrease length of stay in hospitals, wanting to improve patient recovery. So maybe we'll see that. Maybe we'll see less invasive orthopedic surgery in the future. And the last point I was going to make in terms of how soft tissue robotics compares to orthopedic robotics is automation. So automation is really just at the research stage in soft tissue robotics, and that's because it's difficult. Soft tissue moves during surgery. As try as you might to register to your pre-op scan, it can move. Now that's not the case with hard tissue. With the right registration, you've got that registration between the bone position in surgery compared to the pre-op scan and the pre-op plan, and so you can implement automation in orthopedic robotics. And I think we'll see that return. I think we'll see it return and become much more adopted than it was in the very early days of orthopedic robotics.
Right.
Yeah, Tom, I saw a question, and it was, did you call it mini strategically? Are you going to have a MIDI and a maxi? And I think this is a great point to answer that question. Absolutely, yes. And the point that Rob has just made is a very good one. I think we obviously have launched T-Mini to appeal to the majority of the market who, for one reason or another, haven't adopted robotics yet. But there are innovators and early adopters in every market, and we are working on a product called T-Max. It is a robotic arm technology, and it is an autonomous robotic arm technology, which means that it will perform the bone resections itself. The surgeon doesn't need to have a hand-on to direct or control the robot. We have experience of that type of technology. At Think Surgical, we had a product on the market for some time called T-Solution 1. It was an autonomous robot. It was approved or cleared by the FDA. That is the predicate device for our T-Max product. Our T-Max product has been developed in partnership with another external partner called Curexo, a Korean technology robotics company. And we are very excited about the future for that technology because it's the obvious next step in hard tissue robotics where you can control the bone, as Rob said, and you're not subject to the motion that you have in soft tissue. So we are expecting that by late 24, Think Surgical are offering a single planning solution for the intake of a CT and then creating a bone model and developing a surgical plan, which can either be executed by T-Mini or by T-Max, and it depends on surgeon preference. So that's the type of innovation that you can bring when you're focused on just the robot. All the other companies are trying to sell more implants. We're trying to be the best possible version of an orthopedic robotics company. So that's why I think our device agnostic or open platform model, some would perceive as a disadvantage. We perceive it as our advantage. It allows us to focus on being the best possible robot and digital surgery provider in the orthopedic space. So thank you for the question about the naming convention, and more to come on T-Max in the future, but I don't want to distract from the work we've done on T-Mini with Sagenti Innovation, because they're my host today.
Great. So unfortunately, we're Tim is having some more technical difficulties, so I'll just run through some of these questions. But just a few questions about the system. Is it active or semi-active? Someone has asked, and then someone asked if there was a haptic boundary. Really quick, you able to address either? Stuart?
Rob, you want to take that?
Oh, Rob, please.
It's not fully active. So I mean, active, I think, if I understand the question correctly, it's referring to an autonomous robot. So T-Mini isn't fully active. Stuart was describing how T-Max would be. And then the other question was about haptic boundary. Well, that's a concept that's in some of the arm robots. This is a different concept. So rather than providing a haptic boundary, as you saw in the video, the T-Mini keeps to the right plane. So it automatically stays on the right plane to allow the pins to be placed in that plane, rather than having haptics guide the surgeon in their use of the oscillating saw to make cuts.
Okay, great. Tim, are you back with us? I'm not sure if Tim can hear. Okay. So the best laid plan. Well, a few questions have centered sort of around data. And Rob, I don't know if you want to address this, but the question as to whether Think Surgical has a data strategy that would allow you to correct real-world data, such as encrypting patient information. And someone else had similarly asked about data before. Data is obviously becoming a big part of surgical robotic system platform. People are migrating from calling it surgical robotics or robotic surgery to digital surgery. We seem to be emphasizing more than just the robotic arm. So Rob, I don't know, can someone speak to what this system is capable of? And maybe Rob, you could sort of speak to the importance of data being part of a strategy going forward. Or you can handle both, Rob, feel free.
Well, let me take the latter question.
Okay.
I mean, that's certainly right. I mean, digital is inherently linked with robotics now. These are very intelligent systems with a lot of data available. But there are a whole host of things you can do with that. I think one of the really interesting ones is using the data that's collected during the surgery and combining that with the preoperative data on the patient and using that to prospectively predict surgical outcome, and then looping that back to inform the preoperative plans. So predictive analytics on how the patient's going to do, and using the clinical data to adjust the preoperative plan. I think that's a really good use of data, and it's easier to do with robotics. And then in terms of the strategy around T-Mini and data, I'll refer to Stuart on that one.
Yeah, we have, as I said, a single planning software called T-Plan. That's where a customer will go to book a surgery, present the CT information, approve a plan for surgery that comes from Think Surgical. As part of that, we have what we call Think Case Manager, where we are managing the flow of information between the customer, the patient, and the company. And we are focused on a data strategy that takes preoperative data and it's subject of another great partnership of ours. We work with a company called Definition Health, a digital surgery company from the UK. So we work. We have a platform that collects patient preoperative information, connects it to the imaging data and the surgical plan, connects that to the information or what we call the session file or log files from the robot. In other words, the details of the exact surgery that was performed, and then connects that to outcome data, which is collected directly from the patient in the early post-operative and recovery period all the way through to longer term. By connecting all of those data points along the continuum, you can develop very powerful insights and very powerful understanding of the optimal care pathway or protocol for different patient types. So yes, data is a huge part of what we're doing, but to get a lot of data, you have to have a lot of usage. To get a lot of usage, you have to have a lot of systems out there. And we're at the beginning of that journey, as I said. We're just about to start shipping our first systems in this quarter. And we're going to be very focused on creating a great customer experience, driving installations and utilization, all the while with an eye on collecting that continuum data. We have built the platform to do it, but that comes once we get some scale.
And will there be some sort of registry to collect the data? Real quick, just quick follow-up.
We will have a collection of all of that data,
okay.
And it will be available to individual contributors.
Great. We've got a lot of great questions here from folks. We're going to try to get to all of them. If we're not able to, Sagentia or Think we'll get back to you privately. So if you see that the clock is ticking and you're worried that we might not get to your question, just ask the question, or ask for a follow-up. Someone will follow up and get back to you. So please don't shy away from asking any questions. There was a great question. I don't know if Tim, if you're with us, or Stuart, if you can take it, talking about Tim's back, about sterilization. How is that handled with this? Is it a conventional autoclave, or then Marty's asking, or do you see perhaps in the future sophisticated handheld devices leveraging plasma sterilization to reduce turnaround times between surgeries? So I'll offer to the panel.
Currently standard steam sterilization or autoclave. Sorry, Tim, on you go. Welcome back.
That's okay, Stuart.
We missed you, Tim. Why don't you take this one?
We're talking about technology, and it's failing me. Terribly. Apologies for my bad connection. So in terms of sterilization, so for the T-Mini specifically, we looked into a number of different sterilization approaches very much early on in the project, in the program. We understood that the various different approaches led to a different device architecturally, and so we also looked at hospital sterilization services as well. So at the time, we felt the optimum approach to sterilizing the device was through using the autoclave. It's readily available in most hospital institutions. It's there. It would be most widely accepted. That in itself did kind of present us with a number of sort of technical challenges further down the line, because we had to make sure that a lot of the electronics which were in the handpiece, which is all autoclavable, could withstand that environment, those pressures and temperatures associated with the autoclave process. So that in itself was a technical challenge that we developed and overcame collaboratively with Think and other design parties along the way. Now that also means that there is a part of the T-Mini handpiece that's not sterilizable. So we also need to make sure that again, the technician workflows, the workflows in the hospital, were also well maintained. It uses processes that they're familiar with, things like that. So that is effectively what we call a smart cell that can be removed from the T-Mini, and that's interchangeable with any hand piece that can be autoclaved. So that can, that would then go onto a charging station within the OR environment, and can be used for the next procedure if it has enough, charge remaining on that smart cell. And it's not just a battery pack. It has all of the intelligence to enable that tracking and control of the attitude mechanism for the articulation as well.
Great.
So a lot of thought went into how where we got to today.
Tom,
Sure.
let me just jump in here for a second, because it's a very important question, but I'm going to come at it from a different perspective. Sterilization is a major challenge in any surgical site, whether it's acute care or a surgery center. What T-Mini and how it works allows the customer to do is a total knee surgery with T-Mini, one tray is T-Mini plus 3 or 4, a couple of trackers and a couple of other devices. It's one small tray. And then you need about 4 or 5 single instruments from the knee set, from whoever makes the knee implants. That is almost nothing compared to 6 or 7 trays of instruments that are normally sterilized for a manual total knee procedure. So T-Mini effectively reduces the sterilization load by as much as 80% compared to manual procedures. And we're very excited about that, because particularly in the surgery center market, that's not only a challenge operationally, but it's a huge cost. And it's a huge cost saving when you use T-Mini.
Fantastic. Well, we're closing in on the end. Real quick, Stuart, just regulatory, where is it available? Where's T-Mini available?
It's available, well, it's cleared for marketing in the United States only at this point in time.
Okay. Someone was asking about Canada. And how long does training take with this sort of device? Is it shorter? Because you're not turning knobs or using joysticks. I guess it would be somewhat simpler.
We're being what I consider responsible. We're going to be studying the first dozen users very, very carefully to understand their learning curve and how quickly they adopt the technology in their operating room workflow. We believe that it will be single digits for in terms of procedures for a surgeon and their operating room staff to become completely familiar with the technology. And this is a technology, because it's got a sterile touch screen, you don't need a robot technician in the operating room for you. This is very simple, intuitive, fantastic graphic user interface and touchscreen. So this is a piece of equipment, just like a power tool, the OR staff and surgeon will be able to use on a daily basis without any technician there to support them.
Great. So we're closing in at the end. We'll wrap up with a open question to Tim and Rob. Folks, if you have more questions that you want to ask, just again, throw them in the Q&A box. So Gentile will get back to you, or think we'll get back to you. So, Rob and Tim Gentile has been working on this system for, I think it was 4 or 5 years at least. You can see the interest it's generating. I think the folks are really excited about the innovation. Where are we headed? What new technologies might we see in joint replacement robotics? What kind of advancements are we looking at? Well, Tim, why don't you go first, just in case we lose you, and then Rob, you can have the final word. How's that?
Sure. That sounds good. I think from a more sort of general perspective, in terms of technology advancement, I mean, there are a couple of areas that are quite interesting to me. One is around autonomy. I know Stuart talked a little bit about T-Max before I got cut off. So he talked a little bit about autonomous robotic systems. And the other one is around the use of AR, so augmented reality, which I think is something which is could be really exciting in this space. In terms of the autonomous robots, so I mean there has been systems which are in use today. Historically, I mean there's the RoboDoc that Stuart mentioned. Adoption of those systems has been pretty low, and I think Stuart, you alluded to a number of reasons why. They're large, they're cumbersome, they're pretty disruptive to the OR layout, the surgical workflow. They may require specialist tools and training and things like that. And there may just be resistance to surgeons to put their trust in an autonomous robot. But the technology is available today. We've heard that it's something that Stuart and Think Surgical will be working on with T-Max. And it just needs to be developed in a way that's going to be beneficial to the surgeon and the workflow, and obviously the patient as well in terms of patient outcomes. I think there are clear benefits to that, and I think the clear benefits from a surgeon perspective are going to be around the working life for surgeons. They can operate for longer. There's a lower sort of demand physically. I mean, total knee replacements it's like woodwork. If you've ever seen a manual procedure, it's you don't get you get pretty strong strong surgeons, and it's also the load on their cognitive side of things as well. So there are benefits in that perspective. In terms of AR, I think it's still in the early stages of development. But I think it was only be a small step to sort of integrate that into existing robotic platforms. I think it would provide. You can imagine it could provide access to 3D anatomical images and models in real time. It may open up more opportunities in minimally invasive procedures as well with smaller robots. And I think it can be easily integrated in the surgical navigation and the virtual planning side of things with real-time patient anatomy. I think that's quite exciting. I think the AR headset technology itself, it's pretty advanced, but I still think it's got a little bit of way to go. So I think there's going to be advances in that area. And as the technology improves and the use in surgery is likely to become less of an obstacle and more of an enhancer. So they're my thoughts.
Stuff now. Lots of cool advances in AR and really enabling the surgeons to stare forward and actually operate as if they would. Rob, last word goes to you. What are we going to be talking about 3 or 4 years from now when we have you back on Device Talks Tuesdays?
Well, we'll be continuing to work in surgical robotics. That's for sure. As you've seen through this session, we've done this significant development with our partner Think Surgical on the T-Mini. We greatly enjoyed doing that. We also work in endoluminal robotics, abdominal robotics, endovascular as well. So I hope that we'll be back on in a year or two, hopefully sooner, Tom, if you'll have us to talk about one of those other robotics developments.
I think we'll always find room for Sagentia innovation on a Device Talks Tuesday. I promise you that. So, well, this has been a great discussion. As I said, thank you for leading it. Thanks to the audience for asking so many great questions. It's always better when you're getting the responses from the audience. And as I said, there's more than we can handle, but Sagentia will coordinate answers for you all. So if anyone else would like a follow-up call from Sagentia, feel free just to type me or something into the text box while I yammer on for the next 30 seconds and close out the session. If you want if you want to connect directly to the fine folks at Sagentia. But well, that was a great conversation. Exciting times for surgical robotics. Stuart, thank you for sharing Think and T-Mini's story. And Tim and Rob, thanks again always for bringing the wisdom and insights from Sagentia Innovation. Thanks for being part of this.
Thank you.
Thank you for the invite.
Thank you.
And thank you all for joining us on Device Talks Tuesdays. We'll be back next week, I think, with another great episode. So please make sure you join us.